break it, make it, and you suck at zero trust. In this episode, we're only going to talk about user authentication and how the application user, and only the application user, is going to log in to our zero trust architecture. We don't care about networking or IAC, that's infrastructure as code for you slow ones, or any of that. We're going to keep it simple and tackle this thing in bite-sized chunks. So first, we need to build our trust algorithm, right? I've gone over what the trust algorithm is. If you're still not sure, go ahead and look at NIST 800-207 and educate yourself. So these are the things that are going to make up your trust algorithm, and they're pretty much all going to be covered in this user authentication. Now, when the user authenticates, they don't typically interact with the threat intelligence and the logs, but you know what? We'll get to that later. Don't worry about this right now, because it's just going to complicate things. Going back to our problem scenario, here's our section of the enterprise. We don't care about anything else. We just care about our sub-enterprise and our own users in Active Directory. Or in our case, Azure Active Directory, because that's what we're going to use to build the system, is Azure services. So we have our two applications. Only one of them is using the database, but everything in between is this black box that is the trust algorithm components. So let's get into the basics. What makes good user authentication? Well, it's something called ABAC for zero trust systems. That is attribute-based access control. And what's included in that are things like geolocation, where you're at, the time of day you're logging in, because if you're logging in at midnight, you're probably not there to work. You're probably there to sleep with your secretary or something. And we also have the source network. Which network are you connecting to? Are you trying to use an application on your cell phone, or are you trying to use a web browser on your work laptop? Now, all of these things are pushed into our access controls or the conditional access policies to make coordinated decisions. And this is going to be what makes up our policy decision point, right? All these different attributes help us build our confidence score to say, hey, this user is cool. This other user is not cool. So let's look at an OV1, or an operational view level 1, of what something would look like without resources. And by resources, I mean everything that's in Azure, Microsoft Azure. We have our user, and we have the device, right? They have to have a device in order to log in. And that device could be anything, but we're going to insert policy entry points there as well. Because a device is important for user authentication, we will talk about that in this video, but you are not ready for it yet, okay? I need you to just focus on the user and those pieces of it. So the user logs in with the device, expanding into the policy enforcement point. Essentially, our cybersecurity domain controller is looking at all the different attributes of the user and comparing them to our own settings to make the decision of, is this guy cool or not cool? Now, I don't know about you, but I haven't met many cool users. They always like to ask me to fix their printer, which is not what I do, obviously. beyond that. But anyways, they're not cool. So all this feeds into the policy decision points, in addition to the device, but again, we're going to get to that later. Now, as they're connected to resources, we're going to have our user and entity behavior analytics in real time make continuous decisions on if this guy is cool or not cool. And that could change at any given moment. The user could be cool until they try to copy a file and download it on a device that's not in our asset database, therefore making them not cool. Because remember, an asset database was part of the trust algorithm. Now, there are some additional decision factors like your network control lists, again, your device hygiene. Is this a cool device? Is this not a cool device? Is this device sick? Now, these two bad boys, they're more related to the application and database themselves, so don't worry about that. I don't want you to get confused. Although we could use data tags to define the coolness of this user, we won't talk too much about that, right? Or maybe we will, because the IT guys are always cooler than human resources. So actually, data tags will be a part of that. Now you also have, again, attribute-based access control and role-based access control, but they're users. So they're not going to have any roles other than users. Again, I don't want to complicate this for you. So let's look at what a diagram would be with the actual resources we're going to use. Now this matches up with this. It's just more precise in describing the resources we're going to use. So right here we have our user. Cool or not cool. And it depends on a lot, right? Maybe I'm getting a little ahead of myself trying to say if they're cool or not. And then you have the device they're logging into the system with. Now, they will first go through the policy entry, where the policy will be enforced. And right here in the Microsoft Azure, we have our conditional access policies, which will be the policy decision point. Now that has rules of its own, but it mainly comprises of the identity in AAD, also their MFA, and also the tags. I knew we were going to use tags. I just forgot when I made this. These are just a few core pieces. Now, additionally, the conditional access policies have their own policies that we're going to set, again, like geolocation to capture impossible travel, as well as what network they're on. Let's put IP. And their time of day. So again, we're matching these up. Now, for the user and entity behavior analytics, we're going to have Defender, Sentinel, because that's AI, and then our log analytics workbook. This is going to aggregate all the data for Sentinel to watch this user to see if they're not cool or cool. It's essentially all user authentication in a zero trust network equates to. Are you cool or not cool? Because honestly, at any given moment, if you try to do something you're not supposed to, you could go from cool to not cool fast. And that's the power of zero trust architectures, is that they can decide if the user is not cool when they were being cool, but then they do something that's just not cool. And that's something like, spit in my milkshake or steal my nickels. Those are not cool activities in general. When it comes to the sub enterprise, they could be trying to access data in this database that they don't particularly have the trust to access, but you know what? We'll tackle that later. We're not here to talk about applications, we're here to talk about user authentication. So for this piece, this is Microsoft Intune, and that's going to be taking on device hygiene. You don't need to worry about that right now. We're going to talk about that later, okay? But Azure AD and the interaction with the system is going to feed into our UEBA and make those decisions if they're cool or not cool. So let's talk about continuous authentication, because I kind of alluded to that right now. Right, our Microsoft Defender is going to say, are you cool or are you not cool? And what decides if people are cool or not cool is your confidence score. I see Microsoft Defender is going to be watching our users, and at any given moment, they could say, hey, you're not cool. By judging these base attributes, how are they logging in? This is your factors of authentication, whether it's biometrics, you have a certificate, or you're using some other authentication, as well as coordinating data policy. And that goes back to stealing my nickels. If you tried to steal my nickels while you were in my house, well, you went from cool to not cool really freaking quick. Don't steal nickels when you're in, and you might get left in somebody's system. So it's a combination of all the attributes in Azure AD, whether it's the identity, who they are, where they're from, where they're at now, what IP they're connecting from, as well as the tags to see if they're HR snitches, like HR likes to do. All right, it takes all of that and builds it into a confidence score that can change continuously. That's how you manage continuous authentication. So all these pieces right here are going to help maintain the continuous authentication piece. So let's look at it a little deeper. This is a more in-depth operational view. Again, we have our user. Now, you may have noticed we're not really identifying how they're connecting. It could be various ways, right? They could be a service account or a non-person entity or a person, and they could use certificates, or they could use, or they have to actually, other forms of multi-factor. So you see right here in the policy enforcement point, it's the combination, the initial combination that requires the initial authentication to get in. And we have our Sentinel deciding if they're cool or not cool, and constantly comparing the user to the Active Directory, the conditional access policies, as well as things like their IP and where they're at. And it's going to feed into your security system here. So these three charts are taken from DoD-CIO Zero Trust Reference Architecture. Would highly suggest that read. So that's just watching the identity of the user. Now, these people, they need devices to log in, right? You're not just doing this from a Nokia phone. You're doing this from various devices and software. And that matters too. The device that you're logging into the system. You see, we would prefer if the device is managed, but in reality, that's just not always going to be the case, and that's okay. We're okay with that. The most important thing is that device has good device hygiene. So this could be, if it's not a managed device, has this device been on the system before? Who's it associated with? How is it connecting to our sub enterprise? Is it acting a little weird? Does it accept scans? These are the kind of questions that are considered in device hygiene. As a matter of fact, let's go a little deeper into that. What makes zero trust different than your typical best practices? So this is just broad scope overview. Again, does your phone accept diagnostic services? Will it send telemetry? That's a nice thing to know to decide if you're cool or not cool. Is it fine with sharing information? And this is just a service view of how a device hygiene is performed within zero trust architecture. Notice the user isn't here anymore. And as I said before, we prefer if your device is managed. However, it's not a deal breaker. The thing is the data that is pulled from your phone, or the level of confidence we have in the device, will determine the level of access of data that this user is able to get. And that's done at the policy decision point. Now our infrastructure hygiene policy enforcement point will be Intune right here. So this is a quick and dirty of user authentication. Highly suggest you check out the DoD CIO Zero Trust referenced architecture, as well as NIST 800-207. Excuse me. I have to cough. I swear I don't have the thing that Robert Downey Jr. has, or whatever JFK's nephew was. But that is a quick overview. So read, please. Understand more so you can see the broad scope overview as well as the specific technology that's going to be implemented for just user authentication. Now, you suck less. Thank you for watching.